Jocelyn Bell has just received the Breakthrough Prize in Fundamental Physics. This is a $3 million award, and it's for her role in the discovery of pulsars in the 1960s. Jocelyn Bell studied for her PhD in physics at Cambridge University under the supervision of Anthony Hewish. In 1967, Jocelyn Bell was looking through the output from the radio telescope equipment that had been developed by Martin Ryle and Anthony Hewish in Cambridge, and she spotted a surprising pattern in the sky. There seemed to be an object that was pulsing dozens of times a second and producing radio waves, and this was so unexpected that Hewish and Bell weren't sure at first whether this was actually a natural object or whether it was the sign of an alien civilization. And it was only when Jocelyn Bell found other examples in other parts of the sky that they realised that this must actually be a natural phenomenon. The following year, in 1968, the astrophysicist Tommy Gold suggested that the pulsars discovered by Jocelyn Bell and Anthony Hewish might be the result of neutron stars. And these were hypothetical objects that had been first proposed in the 1930s. And the idea was that in a supernova explosion, the core of a star of the mass of the Sun or more would collapse down to nuclear densities to form an object just 20 kilometres in diameter, formed almost entirely out of subatomic particles known as neutrons. And this collapse of the star from an object that might have more than 1 million kilometres diameter down to such a tiny object increases the rate of spin until, when formed, a neutron star is thought to spin at over 100 times a second. And the collapse produces a huge magnetic field, and this magnetic field blasts out beams of particles from the magnetic poles of the neutron star, and this produces radio waves. And these beams of radio waves are what are detected when we see a pulsar. So each spin of the neutron star sends around the beam of particles, and when the beam points in our direction, we detect a pulse of radio waves. And these can be detected like hundreds of times a second, depending on how fast the neutron star is spinning. In 1974, Martin Ryle and Anthony Hewish were awarded the Nobel Prize in Physics for their roles in the discovery of pulsars. However, Jocelyn Bell, whose role was pivotal in the discovery, was not included in the award, and this caused a great deal of controversy at the time, controversy which lingers on to the present day. How ironic that today Jocelyn Bell is far more well known to the public than either Anthony Hewish or Martin Ryle. As she said herself, if she'd won the award, it would have been headline news for a week, and then perhaps forgotten. In 1974, Russell Hulse and Joseph Taylor used the giant radio telescopes to Arecibo in Puerto Rico to search for more examples of pulsars. They found numerous pulsars, but one stood out as being really rather special, because the signal of the pulsars varied over a period of about 7¾ hours. They deduced that this was actually a signal from a pair of neutron stars, one of which was producing a pulsar which pointed its beams in our direction. And the variation in the signal was due to the Doppler effect when this neutron star orbited around its partner neutron star. And because of the incredible regularity of pulsar signals, it was possible to map out the orbits of these two neutron stars with exquisite precision. And the analysis of this orbit enabled Hulse and Taylor to test general relativity in ways that had never been done before. And the most important of their discoveries was that this binary neutron star system was emitting gravitational waves. They didn't actually detect the gravitational waves, but they showed that the orbit was decreasing in size at a rate that was consistent with the emission of gravitational waves. So essentially, gravitational waves were actually discovered long before they were detected here on Earth by the LIGO gravitational wave detector. Neutron stars have been in the news again recently. The gravitational wave detector LIGO in America recently discovered a signal from a collision of two neutron stars in the distant universe, and simultaneously this was picked up as a gamma ray burst by a satellite. This collision and the explosion it's produced are now one of the most observed objects in the history of astronomy. These objects, or these collisions, are quite incredible because physicists believe that the bottom half of the periodic table, that's all the heavy atoms that we're familiar with, were created in these sorts of collisions. So atoms of mercury, uranium, lead and gold ultimately arrive from collisions and the nuclear processes that result, the collisions of neutron stars. So when you look at the gold ring on your finger, all the atoms in that gold must have been produced in a neutron star collision somewhere long ago in the depths of the universe, which is quite a remarkable thought.